So we're waiting for the variable to drop there. We're not giving him any attention. And we're going to see if his function for getting bored works. When it drops below 35, he'll have a random chance of farting or asking you to run a program. And when he farts, he gets a goofy face. So we'll see how well all that works. Some of you may have also noticed I've incorporated a little bit of delay between the eyes randomly so that he blinks a little off. Sometimes one eye will blink a little more faster than the other eye does. But let's see if he does his board routine or not here. Oh, and there's the funny face. He farted. Yeah, it worked. And with that, that's probably a good segue into his software bit here. So, with all due, let's get into some of that, huh? So our last spot was the mechanical overview, and we discussed all of his mechanical components and how those worked and came together to make him. So now let's get into some of the gritty software, huh? Right here, this is the function call that I use for his boredom. You can see it's actually really simple. It's just a random number, and if that number is one thing, then he'll ask you for attention. If it's another thing, then he'll fart. Pretty simple, right? We use another function in our list. Let's see if we can find that real quick. Here we go. This is under the check stats function, and it lists out all of his stats for the Tamagotchi stuff. So if his attention's under 35, then obviously he's bored because he's not getting any attention, right? It'll bang out a message across the debug line, and then it goes from there, whether it's going to call a function or not. So his software is actually pretty interesting. As he's a multi-processor system, we actually use 3 separate pieces of software here. Last count that I did on this, he had roughly, I want to say 5,000 something. Let's see, where's it at? Yeah, 5,612 lines of code the last time I counted them total that we've written to make him function and do all the cool stuff he does. This is a .h file, but it doesn't actually hold any software. I just use it for notes. And something I recommend everybody does is anytime you make a major change in your software for your machine, save it as a new version first and then modify it, because then if you mess it up, you can always go back to the previous version before you added whatever it is you were working on and go back and see how it worked, and then it makes it a lot easier to fix it. This is my Arduino folder, and it's got all the various code snippets for all the stuff that I've played with over the years, all the components I've bought and played with. But right now we're just working on Crash, so we'll open his folder. Now, since the beginning, I've kept versions from version 1 all the way to the current 2.4 that we're working on now, and not just for the ESP, which is the main brain, but remember we have the TTS board as well, and we have the camera. So we'll start with some of these because they're much smaller and much simpler. His text-to-speech board runs this sketch, and this is one of the 3 main sketches here. These are the 3 main sketches that we edit regularly to give Crash his abilities and his interactions and make him do what he does. And this is really simple. At the top I got some notes for various parts of it. This is how to build the filter in case I have to build the filter again. It's supposed to reduce the clicks and pops, but doesn't do it too well. I use a library, which is the Talkie library, and then these are the .h files that include different vocabulary pieces. These can actually be edited, and I use a program for that called Visual Studio Code, and I edit the vocabulary files in that. I don't have anything new to show off at the moment because I haven't quite figured out all the, see if I can say the word correctly without butchering it, phenoms, but I am still working on that. I've been breaking down the other words and the string of data that's used to make those words, and I'm pretty close to cracking which. I'm making a list. I would show it, but it's like super messy, so it's not worth getting into. But I'm making a list of all the different chunks of code and the sound that that chunk of code makes, so that I can use those to build more words for different vocabulary files, and then we can give him more things to say. But this is really simple because the TTS board is used as an I2C device. All we have to do is receive a command over the I2C bus. So this is the included library for the MP3 player that it triggers to, and then it uses software serial for that. We have to attach a device for that, and the Talkie library requires you attach a device to. So have some pin setups, and then we have a void function here, which is the receive event for the I2C, which is part of the SPI in the wire library. And all it does is when you receive an event over I2C, which is address 8 for this, which is set right here on that line, it receives the number, and whatever the number is, it bangs out that option. So from 0 to 255, we've got a whole list of case statements here. And then towards the end, we used from case 200 to the end, what did we do, 250, I believe, to do the MP3 functions, which worked out really well because we have way more options than we need for that. But we can keep adding audio files to the MP3 thing if we want to. So we've got plenty of room for expansion here. Setup is also really simple. Pin mode for the LED that comes on when he's talking. We begin the wire library, set up the receive event, the serial, set up the serial MP3 player with its requirements, and then the loop doesn't do anything. It just kind of sits there and hangs, and it waits for a receive event, because on its own it doesn't really do anything other than talk. So if it doesn't need to talk, it just sits idle. And then down here are all the void functions. If you know case statements, you realize these are function calls, just like the words that he speaks up here. It prints out what it is he's going to say, but then there's a function call, and that's used to call these functions down here. So like 9, that's how he says 9, and then we've got the variable for the delay. That turns the LED on and off when he's talking and when he's done talking. And that's part of the Talkie library, the voice.say. And then these are the actual code function calls in the .h vocabulary files. And those are the actual words. So you'll see for 13, we actually use 2 different chunks of wording here. We use thir and the word teen. And I could break this down, and I could make teen its own word as well if I needed him to say the word teen as part of an answer or something of that nature. Further on, we have other examples of breaking down the different sounds and words to make different things said too. Some words I just don't have, so I had to improvise, like EYE I don't have, so anytime he has to say something that sounds like I just use the letter I. I don't have a word am, as in AM, so I just use the M. And it sounds alright when he talks. It really does reference more like a 1980s era speak and spell, which I like. That was the goal of using this board for his speech instead of, say, another device, which we really could have done. We used the library up here. This app does the speech function, so when we talk, this hears us, and then it sends that data string over Bluetooth to the ESP, so it can decode that and respond based on that. But this can also receive data via Bluetooth from Crash, and it has its own voice, and any chunk of text that we send from that to this will speak, and it can say any word we send it. So there was an option of doing that too, but he wouldn't have sounded like I want him to sound like, so we stuck with the board to pay homage to the old classical robots. Another piece of software we use regularly is the face tracking software. I'm going to be pausing this video here shortly, and I'll start another video. I have to keep my upload times short, or Facebook doesn't like to accept them. but we should be able to get this chunk out real quick, and then I'll do another video over his main code for the ESP. So this is how he sees, and that's the little camera that's installed between his eyes, and it's an ESP32 cam. And all this does is it looks for a face. I still don't know what this means. I haven't figured that out yet, but I know that it works. And then these are pinouts for the camera modules that are used. So those two files are incorporated into this as well. But this just looks for a face, and when it detects the face, there's no web interface on this, which makes it faster. It's all done in-house. It'll determine where in the window it thinks the face is, and instead of drawing a box around it, it just saves those numbers in variables. And towards the end of this, right here, it actually takes those variables and it spams them out across the serial bus. Anytime it detects what it believes is a face, it'll tell you the pan, the tilt, and then its estimated distance from itself that it believes that face, or I believe you can redo it to do object recognition. Instead of a face, it'll look for a vase or a cup or whatever. But we use start and end markers to decode the different pieces of data once it's sent to the ESP. So that's how we do that, and then I'll show you the receiving port on that one. We're already up to 12 minutes, so I'm gonna stop this, I'm gonna make sure it uploads, and then we'll get on with the rest of it.